The shores of Atlantic Canada and the coast of Maine, New Hampshire, and Massachusetts down to the tip of Cape Cod make up the boundaries of the Gulf of Maine. The Gulf is known the world over for its flourishing populations of shellfish, mammals, and seabirds. For hundreds of years, the Gulf's bounty has fed the region's inhabitants, provided thousands of jobs, and sustained the unique cultural character of its coastal communities. But as humans continue to burn fossil fuels to power our global industrial economy, the Gulf's marine ecosystem has become threatened by warming ocean temperatures and the changing chemistry of the air and oceans. While about half of the carbon dioxide burned from fossil fuels stays in the atmosphere, about 25% of it goes into the ocean, which is why we call it a carbon sink. The big problem is that when CO2 goes into the ocean, it reacts with seawater to form corrosive carbonic acid. As the carbonic acid breaks down, it releases hydrogen ions which combine with carbonate in the water, inhibiting the formation of the vital molecule calcium carbonate. Creatures like clams, lobsters, mussels, shrimp, scallops, oysters, sea urchins, and corals use calcium carbonate as the building blocks to form their shells. With fewer calcium carbonate molecules, they have to spend more energy for shell production, which hinders their ability to grow. And if the water gets too acidic, it could even dissolve their shells. Scientists also believe that the Gulf of Maine is especially vulnerable to acidification because of the complex flow of freshwater from the region's many large rivers, as well as cold freshwater from the Gulf of St. Lawrence and snow and ice melt brought down from the Arctic by the Labrador Current. Because carbon dioxide is more soluble in cold water and freshwater has lower concentrations of carbonate and calcium ions, the region's unique geography further exacerbates the acidifying effect. Scientists also worry about nutrient loading, which is when the waste nitrogen and phosphorus from sewage, livestock, fertilizers, and various industries run into the ocean, stimulating massive phytoplankton blooms. Excessive phytoplankton produces even higher levels of CO2 as they decompose, which makes the waters more acidic, especially around coastal mudflats and salt marshes where mussels, clams, baby oysters, and other sea larvae thrive. Rain and snowfall also increases the level of runoff that brings nutrients into the Gulf, and the warming climate is expected to bring even more precipitation to the region. With rapidly melting polar ice caps and more rain and snow, the Gulf of Maine shellfish could be facing a perfect storm of acidifying waters, as ocean acidity has already increased by a whopping 30% during the last 70 years alone. Normally, the ocean waters would be able to take in all that CO2 without too much trouble, but because the chemical changes are happening much faster than any naturally occurring changes during the past 200,000 years, many scientists believe the ocean life may not be able to adapt to it fast enough. And although ocean acidification may be more harmful to some marine animals than to others, the Gulf of Maine is an intricate food web. The death of one species may cause permanent changes to the entire Gulf's marine ecology. But this time, we can do something about it. In addition to taking action on reducing CO2 emissions, we also need to learn more about the causes and impact of ocean acidification on our most treasured Gulf of Maine resources, and our way of life. Humans may have contributed to the acid in the oceans, but we can also take steps to stop it. To find out more, visit www.necan.org.